Hey everyone, so we're going to be taking our guided notes a little bit differently today. Instead of doing it in the front of the classroom, you guys are going to be using our Edpuzzle video to follow along with your notebooks in the back on your own. So throughout this video, feel free to pause it to write down things, work through it at your own pace, but make sure that you are getting all of our notes written down. Now before we start, you'll notice that I have a white piece of paper and a black piece of paper set on the cement wall right by my window. About halfway through this presentation, you're going to have to get up and go do something with those pieces of paper. So be ready and make sure that when you do that, you are doing that without talking and without distracting your other classmates. Thank you guys. Okay, so we're going to get started. So we should be on page 14 of our notebooks, and I should be able to open it. So we're starting off with electromagnetic energy, and that is energy that travels in the form of waves. We've spent our last unit talking about two different types of waves. Electromagnetic energy is going to travel as one of these types of waves, and this is going to be the first question that we have. Yeah, so electromagnetic energy always travels as a transverse wave. And we know that a wave is a disturbance in matter that transmits energy. So we've learned about light so far in the electromagnetic spectrum, but electromagnetic energy can actually travel as radio, visible light, UV, and many other types of waves. And that's what we're going to be focusing on today. So you have learned that thermal energy can be felt in the form of heat. So not only does heat warm objects, but electromagnetic waves can also warm objects. So when you feel the sun's heat, that's not thermal energy that you're feeling. That is actually electromagnetic energy. An object's temperature is the measure of the heat of an object. And we're going to be looking at how electromagnetic waves interact with temperature. So the first thing that happens is that light warms the object. So the amount of temperature increase is related to the light intensity, the length of time that the light shines on an object, and how much light is absorbed. So we have talked a little bit about the word absorbed. We've seen it a couple of times in class. But today we're going to be focusing on what actually happens when light is absorbed. So this is what I was talking about. There's that white piece of paper and that dark piece of paper sitting on the windowsill. Those have been sitting there for about 15 minutes. So go ahead now, stand up, go over, touch each paper, leave it there for your other classmates to experiment with as well. But then record your observations for each piece of paper in your notebook. And I need you to tell me why there's a difference between the two pieces of paper. So the transmission of light. This occurs as light passes through something. So eyeglasses transmit more light than sunglasses. Why is that? Right, so eyeglasses would transmit more sunlight than sunglasses because they are transparent. The purpose of sunglasses is to protect your eyes from the sun. So if they let all the light through, they would be useless. The next vocabulary word that we're going to focus on is refraction. Refraction occurs when light is bent as it enters a substance and changes paths. So this word should look a little familiar. Not only was it our homework last week, but also we have heard the word fraction used in our last unit when we were separating out white light into the different colors. This picture should look familiar. We did not have a triangle prism, but we used that small diffraction gradient over our projector to take the white light and separate it out on our board into all the different colors of the rainbow. So reflection of light. Our definition, or explaining what happens when light is reflected, it's when light is not absorbed or taken in. So it may occur as light is scattered and dispersed as a color. Now this is the reason that the sky is blue. We see that example written down there. When light is reflected, the blue color is scattered and dispersed throughout our sky. That wavelength is not absorbed, and that's why when you look up, you see that our sky is blue. So this is a picture of our electromagnetic spectrum. With me in the front of the classroom, you're going to be working on getting definitions and examples for each of these types of waves. But while you are back here, I'm going to have you color in the image that you see on the top of page 16 that looks similar to this, except it's a straight line, the way that you see it. So we're starting with a darker red, lightening up, and then a light purple going to a dark purple. You can choose 2 other colors besides purple and red if you would like. The only part that we cannot change is where we see spectrum of visible light. So you see that large empty bar that is pulled out on top of your paper? You need to color that one with the colors of our rainbow in order from red, orange, yellow, blue, indigo, and violet. So color in the top of page 16 your electromagnetic spectrum to look exactly like this. If you have your own colored pencils, feel free to use them. Once you are done with that, continue on to the video for final instructions. Okay, so we're completing the questions on page 15 in your notebook. I'm going to have them pop up on the Edpuzzle video as well, so that way you will earn credit for answering these questions as I go through and grade them. Thank you guys for filling in your guided notes. I'm very excited to see everyone in the front of the classroom. I hope you guys had a good time. Bye. Oh, that's not the right button.